Hi friends, ಇವತ್ತು ನಾವು ಕಂಟಿನ್ಯೂಟಿ ಆ್ಯಂಡ್ ಡಿಫರೆನ್ಸಿಬಿಲಿಟಿ ಪಾರ್ಟ್ 4 ಅನ್ನು ನೋಡ್ತಾ ಇದ್ವಿ. ಪಾರ್ಟ್ 3 ಅಲ್ಲಿ ನಾವು ಕಂಟಿನ್ಯೂಟಿ ಆಟ್ ಎ ಪರ್ಟಿಕ್ಯುಲರ್ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ತುಂಬಾ ಎಕ್ಸಾಂಪಲ್ ಅನ್ನು ಸಾಲ್ವ್ ಮಾಡಿದ್ವಿ. ಪಾರ್ಟ್ 4 ಅಲ್ಲಿ ನಾವು ಆಟ್ ಎ ಪಾಯಿಂಟ್ ಜೊತೆಗೆ ದ ಫಂಕ್ಷನ್ ಈಸ್ ಕಂಟಿನ್ಯೂಸ್ ಇನ್ ಹೋಲ್ ಡೊಮೇನ್ ಅನ್ನು ನೋಡ್ತೀವಿ. ಹಾಗೆ ಸಪೋಸ್ ದ ಗಿವನ್ ಫಂಕ್ಷನ್ ಈಸ್ ಕಂಟಿನ್ಯೂಸ್ ಅಂತ ಕೊಟ್ಟಂತ ಫಂಕ್ಷನ್ನಿನಲ್ಲಿರುವಂತಹ ಅನ್ನೋನ್ ಕ್ವಾಂಟಿಟಿ ಅನ್ನ ನಾವು ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ತೀವಿ. ಫಸ್ಟ್ example, discuss the continuity of the function f of x is given by f of x is equal to x square if x is less than or equal to 0. Its value is equal to 1 minus x if x is greater than 0. We are discussing at x equal to 0. Is problem anna discuss ಮಾಡ್ತೀವಿ. Here the given function f of x equal to x square if x is less than or equal to 0. Its value is 1 minus x if x is greater than 0. We are discussing at a point x equal to 0. Here at a point x equal to 0, first find the value of the function at the point x equal to 0, f of 0 values. Here f of x is equal to x square. Therefore, put the value of x equal to 0. 0 square means 0. Value of the function is 0. It is defined. Next, find the limiting value of the function. Before finding the limiting value of the functions, first observe the given function. F of x is given that x square x is less than or equal to 0. Less than 0, this curve x square, and greater than 0, x is greater than 0, its value is 1 minus x. It means the piecewise functions. At the point x equal to 0 is a turning point, you say that. Therefore, here finding the left hand and right hand limits. First find the left hand limits of the function at the point x equal to 0. The notation is the limit of f of x as x tends to 0 minus its value is equal to limit of f of x values x is less than 0. The function is x square. Therefore, limit of x square as x tends to 0. It is a polynomial. Therefore, put x is equal to 0. You get 0 square means 0. This value is exactly equal to value of the functions. Similarly, find the right hand limits. Limit of f of x as x tends to 0 plus that value is equal to 1 minus x. X is greater than 0. The function is 1 minus x as x tends to 0. It is also polynomial. Here put the value of x equal to 0. You get 1 minus 0 means 1. 1 is not equal to 0. Therefore, this function is limiting value is not equal to value of the function. The function value is 0. It means you come to the conclusions. The limit of f of x as x tends to 0 minus, it means left hand limit is equal to value of the function, but this value is not equal to right hand limits. Limit of f of x as x tends to 0 plus. Therefore, by definition of continuity, you say that f means the given function is discontinuous at x equal to 0. Very simple proof. First find the value of the functions, left hand limit, right hand limits. Here you know that left hand limits and right hand limits is not equal to value of the functions. Therefore, the function is discontinuous. Next examples we discuss in whole domain. Discuss the continuity of the function f given by f of x equal to x if x is greater than 0 and its value is equal to x square if x is less than 0. Here discussing the whole domain of the functions. Therefore, first identify the domain of the given function. Here domain of f is given that x is negative. Negative means all negative real numbers minus infinity to 0. X positive, x is greater than 0. It means 0 to infinity. And x is equal to 0, singleton set 0. Therefore, the domain of the function f is d1 open interval minus infinity to 0 union d2 open interval 0 to infinity, union D3, singleton set 0. Therefore, the domain of the function is set of all real numbers. One by one, verifying at any point in D1, you can take in any negative real numbers. You know that the given function is f of x is equal to x square, not x square. X square means it is a polynomial function. Therefore, this every polynomial function is continuous. You know that the properties of continuity for all real numbers. Here, f of x equal to x square for all x is less than 0 means belongs to the interval minus infinity to 0. It is a subset of set of real numbers. Therefore, this function is continuous. For all negative real numbers, the function is continuous. Similarly, at any point in D2, f of x is given. X is an identity function. You know that in properties of continuity, identity function is continuous for all real numbers. Here also f of x equal to x square in D2. D2 means open interval 0 to infinity. Open interval 0 to infinity is a subset of real number. Therefore, f of x is continuous. In D1, function is continuous. In D2, the function is continuous. Next, verifying only at the particular point x equal to 0. Here verifying at x equal to 0. Here find the value of the functions at the point x equal to 0. You know that value of the function equal to 0. Here also, here find the limiting values as x tends to 0. X tends to 0 means the given function is piecewise function. 0 is the turning point. Therefore, finding the left hand and right hand limits. Left hand limits, limit of f of x as x tends to 0 minus its value is equal to limit of x square, not x square as x tends to 0. This value is 0. And right hand limits as x tends to 0. The limit of f of x as x tends to 0 plus this value is equal to limit of x is greater than 0. The function is x. Limit of x as x tends to 0 is equal to 0. Here you know that value of the function is 0. Left hand limit is 0 and right hand limit is also 0. It means left hand limit is equal to right hand limit is equal to value of the functions. Therefore, by definitions, you say that f of x is continuous at the point x is equal to 0. Therefore, you say that the function is continuous in D1, in D2, and in D3 is also. Therefore, f is continuous at every point in its domain. Therefore, our conclusion is the given function is continuous function. It's clear? A similar way, one more example. Discuss the continuity of the function f defined by f of x is equal to x plus 2 if x is less than or is equal to 1 and its value is equal to x minus 2 if x is greater than 1. Here also, in whole domain, verify this function is continuous or discontinuous. Here also, first identify the domain of the given function. X is less than 1 means minus infinity to 1, open interval. X is greater than 1 means open interval 1 to infinity. And x is equal to 1 means singleton set 1. Therefore, the domain of the given function f is D1, open interval minus infinity to 1, union D2, open interval 1 to infinity, union D3, singleton set 1. Its union is exactly equal to set of all real numbers. Therefore, domain of the given function is the set of all real numbers. Here discuss this the continuity for all real numbers. First find take at any point a in D1 or you write directly at any point a in D1 you write f of x is equal to minus infinity to 1 means the given function is equal to x plus 2. It is a polynomial function, therefore it is continuous. Or you can take at any point a in D1 value of the functions f of a is equal to a plus 2 and Limit of f of x as x tends to a is equal to limit of x plus 2 as x tends to a. You know that this one is a polynomial values, therefore its value is a plus 2. A plus 2 is exactly equal to f of a. It means the limit of f of x as x tends to a equal to f of a. Therefore, the given function is continuous at any point in D1. It means x is less than 1. The function is continuous. Thus, f is continuous at all real number less than 1. Similarly, at any point a in D2, here find the value of the functions f of x is x minus 2. Therefore, value of the functions at the point x equal to a is a minus 2. Next, find the limit of f of x as x tends to a. Limit of f of x tends to a, x is less than 1. Therefore, the given function is x minus 2. X minus 2 is polynomial functions. Therefore, limit of x minus 2 as x tends to a equal to a minus 2. This a minus 2 is exactly equal to value of the functions at the point x equal to a. Therefore, by definition of limit of f of x as x tends to a is equal to f of a. Therefore, f is continuous at all real numbers greater than 1. Or simply you said that at any point a in D2, f of x is equal to x minus 2. X minus 2 is polynomial function. All polynomial functions are continuous. Therefore, the given function is continuous at all real numbers greater than 1. Next, here verifying at the point x is equal to 1. First, find the value of the functions f of 1. F of 1 is equal to 1 plus 2. Its value is 3. 3 is a finite real number. Therefore, the function is defined at the point x is equal to 3. Next, find the left-hand limits. The limit of f of x as x tends to 1 minus f of x values x is less than 1. Its value is equal to limit of x plus 2 as x tends to 1. Its value is also 1 plus 2 is equal to 3. Here also left-hand limit is a finite real number, therefore left-hand limit is exists. Next, find the right-hand limit as x tends to 1. Limit of f of x as x tends to 1 plus. Its value is equal to limit of x minus 2 as x tends to 1. Its value is equal to 1 minus 2 is minus 1. Here, right-hand limit is a finite real number, therefore right-hand limit exists. But here you know that left-hand limit is 3. Its value is equal to value of the functions, and right-hand limit is minus 1 is not equal to 3. It means not equal to value of the functions. Or you said that left-hand limit is not equal to right-hand limits at the point x is equal to 1. Therefore, limit does not exist. Limit does not exist means f of x is discontinuous at x is equal to 1. Here in a D1, the function is continuous. In D2, the function is continuous. But in D3, singleton self 1, the function is discontinuous. Therefore, totally you say that the given function f is discontinuous function. It is not a continuous. Remember, at x equal to 1 is only point of discontinuity of the given function. This function is continuous except x is equal to 1. At the point x equal to 1, this function is discontinuous. And this x is equal to 1 is called the point of discontinuity. Next problem. Discuss the continuity of the functions defined by f of x is equal to sin x divided by x if x is less than 0, and its value is equal to x plus 1 if x is greater than or equal to 0. Here also, identify the domain of the given function. X is less than 0 means all negative real number. X is greater than 0 means all positive real numbers, and including x is equal to 0. Therefore, domain of the function f is open interval minus infinity to 0 union open interval 0 to infinity union 0. That is the set of real numbers. Next, verifying one by one at any point a in open interval minus infinity to 0. Here, you know that the value of the functions f of a is equal to sine a divided by a. It's a finite real numbers. And the limit of f of x as x tends to a is equal to limit of sine x divided by x as x tends to a. This is also is equal to sine a divided by a. Its value is equal to value of the functions at the point x is equal to a. Here a is any arbitrary point in open interval minus infinity to 0. Therefore, the given function is continuous at all real number less than 0. It means negative real numbers, this function is continuous. Similarly, at any point a in open interval 0 to infinity, the value of the functions f of a is equal to a plus 1, and the limit of f of x as x tends to a is equal to the limit of f of x as x tends to a. Here a belongs to the open interval 0 to infinity. The function is x plus 1. The limit of x plus 1 as x tends to a is equal to a plus 1. That value is equal to f of a. It means the limit of f of x as x tends to a is equal to f of a. Therefore, by definition of continuity, f is continuous at all real numbers greater than 0. It means in negative real numbers, the function is continuous. In positive real numbers, the function is continuous. Next, verifying only at the point x is equal to 0. At the point, it is a particular point. Here, first find the value of the functions. At the point x equal to 0, you know that 0 plus 1, its value is 1. F of 0 is equal to 1. 1 is a finite real number. Therefore, the function is defined at the point x is equal to 0. Next, find the left-hand limits. The limit of f of x as x tends to 0 minus left-hand side of 0. Left-hand side of 0, the function is defined sin x divided by x. We are finding the limit of sin x by x as x tends to 0 is the standard result. Its value is equal to 1. 1 is a finite real number. Here left-hand limit is exist and its value is equal to 1. And find the right-hand limits. Right-hand limit of the given functions at the point x is equal to 0. The right-hand limit is limit of f of x as x tends to 0 plus this value is limit of x plus 1 as x tends to 0. It's a polynomial functions. Just put the value of x is equal to 0, 0 plus 1 is equal to 1. It means here value of the function is 1, left hand limit is exist, its value is 1, right hand limit is exist and its value is 1. Here left hand limit is equal to right hand limit is equal to value of the functions. Hence the given function is continuous at x is equal to 0. Therefore, you said that the function is continuous in open interval minus infinity to 0, continuous in open interval 0 to infinity, and also it is continuous at the point x equal to 0. Therefore, we can say that f is continuous at every point in its domain. Therefore, conclusion is the given function f is continuous functions. Clear? Next, type problems. Suppose the function is continuous, given that the function is continuous at a particular point or in whole domain, we are finding the unknown quantity of the given function. Here given that the function f of x is equal to 3ax plus b if x is greater than 1 and its value is equal to 11 if x is equal to 1 and its value is equal to 5ax minus 2b if x is less than 1. Given that this function is continuous at the point x is equal to 1, then find the value of a and b. Given that the function is continuous at the point x equal to 1, then find the value of a and b. First, given that f is a continuous at x equal to 1, by definition of continuity, it implies limit of f of x as x tends to 1 minus is equal to value of the functions f of 1 is equal to right hand limits limit of f of x as x tends to 1 plus. Let's substitute the value of f of x, f of 1 values in left hand side of 1 and right hand side of 1. In left hand side of 1, f of x value is 5ax minus 2b, and right hand side of 1, f of x value is 3ax plus b, and f of 1 value is 11. Therefore, limit of 5ax minus 2b as x tends to 1 is equal to 11. Its value is equal to limit of 3ax plus b as x tends to 1. Next, calculate these limits. It implies 5ax minus 2b is a polynomial function. Here, just put the value of x equal to 1, we get the equations 5a minus 2b is equal to 11. And right hand limit is also limit of 3ax plus b as x tends to 1. 3ax plus b is also polynomial function. Here also put the value of x equal to 1, we get 3a plus b is equal to 11. Then you said that 5a minus 2b is equal to 11, first equation, and 3a plus b is equal to 11, second equations. These two equations are simultaneous equations, unknown quantity a and b. Solving these equations 1 and 2, we get the value of a equal to 3 and b is equal to 2. Suppose here multiplying the second equations by 2 and subtracting, you get a is equal to 3. Put the value of a is equal to 3, either equations 1 or 2, you get the value of b is equal to. Similarly, one more problem. Find the relations between a and b so that the function f is defined by f of x is equal to ax plus 1 if x is less than or is equal to 3, and its value is equal to bx plus 3 if x is greater than 3. Given that this function is continuous at x is equal to 3. F of x is continuous at x is equal to 3. Solutions. Given that f is continuous at x equal to 3, here using the definitions. Limit of f of x as x tends to 3 minus is equal to f of 3. This value is equal to limit of f of x as x tends to 3 plus left hand limit is equal to value of the function is equal to right hand limits. Let's substitute the value of f of x values when x is less than 3 and x is greater than 3. Therefore, this implies limit of ax plus 1 as x tends to 3 is equal to 3a plus 1, the value of the functions here, put x is equal to 3, is equal to limit of bx plus 3 as x tends to 3. X is less than 3, the function is ax plus 1. X is greater than 3, the function is bx plus 3. And value of the function is 3a plus 1. It implies, evaluate this limit, just put the value of x is equal to 3, 3a plus 1 is equal to 3, 3b plus 3. Evaluate left hand limits and right hand equating, we get 3a plus 1 is equal to 3b plus 3. Simplifying, we get 3a is equal to 3b plus 3 minus 1. It implies 3a is equal to 3b plus 2, or right, a is equal to b plus 2 divided by 3. It is the relations between a and b. Similarly, one more problem. It's very important problem in our textbook. Determine the value of k. F of x is equal to k times cos x divided by pi minus 2x if x is not equal to pi by 2, and its value is equal to 3 if x is equal to pi by 2. Given that this function is continuous at x is equal to pi by 2. Find the value of k. The function f of x is continuous at x is equal to pi by 2. Here also, f of x is continuous at x equal to pi by 2 means it implies limit of f of x as x tends to pi by 2 is equal to f of pi by 2. Here not find the necessary to find the left hand limits and right hand limits because x is not equal to pi by 2 means either greater than pi by 2 or less than pi by 2, the functions defined single functions k into cos x divided by pi minus 2x. First, find the value of the functions. Here given that at the point x equal to pi by 2, f of x is equal to 3. Therefore, f of pi by 2 is equal to 3. Next, find the value of the limits. Limit of f of x as x tends to pi by 2. As x tends to pi by 2 means x is not equal to pi by 2, either less than or greater than pi by 2. Its value is equal to limit of k times cos x divided by pi minus 2x as x tends to pi by 2. Suppose here put the value of x equal to pi by 2, you know that cos pi by 2 is 0. And here put the value of x equal to pi by 2, 2x is equal to pi. It means pi minus pi means 0, 0 by 0, indeterminate forms. Therefore, simplify or reduce it into standard forms this limit. Just substituting methods. Put the value of x is equal to pi by 2 plus x. Here, taking x is equal to pi by 2 plus h, it implies as x tends to pi by 2, then you get h tends to 0. Here substitute the value of x. Therefore, this limit is equal to limit of k times cos of x is replaced by pi by 2 plus h, cos of pi by 2 plus h minus pi minus 2 times pi by 2 plus h as h tends to 0. This value is equal to k times cos of pi by 2 plus h. You know that pi by 2 plus h lies in second quadrant. In second quadrant, cos is negative and name is changed. Its value is equal to minus sin h. And remove this bracket, pi minus 2 into pi by 2 plus into minus minus 2h. Here 2 is cancelled. You get limit of k times minus sin h divided by pi minus 2h. Here plus pi minus pi is cancelled. K is a constant outside. 2 is constant outside. You get limit of minus sin h divided by h. Minus by minus is plus. This one is the standard limits. Limit of sin x divided by x tends to 0. You know that its value is equal to 1. Therefore, the value of the limit is equal to k divided by 1. So then this one is the second result. By using result 1 and 2, you know that value of the function is equal to value of the limits. It means 3 is equal to k by 2. Just cross multiplications, you get the value of k is equal to 6. One more problem, the last one. Find the value of a and b such that the function is given by f of x is equal to 5 if x is less than 2, and its value is equal to ax plus b if x is greater than 2 and less than 4, and its value is equal to 21 if x is greater than 10. Is continuous function. We are given that the given function f of x is continuous functions. It is a continuous function means it is defined continuous for all real numbers. Here the domain of the functions f of x is less than 2 means minus infinity to 2. X between 2 to infinity means 2 to 10 open interval, and x is greater than 10 means open interval 10 to infinity, and x is equal to 2 singleton set 2. X is equal to 10 singleton set 10. Therefore, domain of the functions open intervals minus infinity to 2 union 2 to infinity union 10 to infinity union singleton set 2 union singleton set 10. It means the set of all real numbers. Given function is continuous means it is continuous for all elements of its domain. Therefore, it is continuous. The given function is continuous for all x in real numbers. It implies f of x is continuous at a particular point x equal to 2 and x is equal to 10. These two is belongs to the real numbers. It is continuous at x equal to 2 and x equal to 10. By definitions, limit of f of x as x tends to 2 minus is equal to limit of f of x as x tends to 2 plus is equal to f of 2. It is continuous at x is equal to 10 means limit of f of x as x tends to 10 minus is equal to limit of f of x as x tends to 10 plus is equal to f of 10. Left hand limit is equal to right hand limit. Its value is equal to value of the functions at the point x equal to 2 and at the point x is equal to 10. Next, substitute the value of the functions. The limit of phi as x tends to 2 is equal to limit of ax plus b as x tends to 2 is equal to phi, and limit of ax plus b as x tends to 10 is equal to limit of 21 as x tends to 10 is equal to 21. Here evaluate these two limits, you get 2a plus b is equal to 5 and 10a plus b is equal to 21. Solving these two equations, you get the value of a is equal to 2 and b is equal to 10. Here given that the function is continuous for all its domain. Then it is continuous at a point x is equal to 2 and at a point x equal to 10. Using these two, you get the value of a is equal to 2 and the value of b is equal to 10. These are the homework. Solve this. Thank you.